Hi guys, welcome back to another STEM experiment. I'm Lauren and I'm going to be teaching you how to make a straw rocket. So I've actually done a couple attempts of these and I kind of messed up a couple times. So this should be the full attempt and I hope to get this right. And I'm explaining that to you because it's okay to make mistakes and it's okay to keep retrying. This is an experiment. It's not supposed to be perfect on the first try. But obviously I want to make the best video for you guys, so I'm going to try to make the best one in the videos. So I did actually record a couple other videos and I had to delete them because they just did not come out right, especially with the rocket. So this is hopefully going to be the right experiment. It's going to go all correct. So further, on other notes, we're going to talk about the materials that we need. So you are going to need some tape, which is right here. You're going to need some scissors, and be careful with the scissors. Always hold them down. I know I just didn't do that, but hold them down so in case you ever fall with them, they won't hurt you. A straw, either a plastic straw or a reusable straw. I only have this plastic straw, so we're just going to stick with that. And you are going to, if you go online, you're going to end up getting this instructions on what to do, and they're going to have all the lists of what you need to do and the things that you need to cut out and the materials that you need. So you're going to get that. It's at jpl.nasa.gov/edu/learn. Just in case if you guys can't find it, I just wanted to let you know that's what the website is. So it's on the NASA webpage for Jet Propulsion Laboratory. It's the California Institute of Technology. So what they say that we're doing is creating a paper rocket that can be launched from a soda straw. Then modify the design to make the rocket fly farther. So we'll obviously do some further advancements to see how far we can make this rocket go. So you're also going to need some measuring tape or a meter stick. Obviously, if you don't have that, if you just have a ruler, you can use that too. But if you have stuff like this, definitely try to using those. Or a tape measure, obviously. So then also what you're gonna need is, it comes when you print this out, it's gonna have a rocket data analysis sheet. So it's gonna have this little chart, which we're gonna do in a couple minutes after we finish the rocket itself. And then you're also gonna get a data log, which is right here. And it comes with the length of the nose cone in inches. And then all the trials, we're gonna do 5 different trials in inches and centimeters, and you take notes. So we're gonna try to keep up with that, but for now, we're gonna start with the steps that we need to do to make the rocket. So it says for step number 1, we're gonna cut out the shape of the body, rocket body. So we need a pencil as well for this. So if you got a brand new pencil, I would definitely try using that's just sharpened, because I originally used this pencil, and as you see, it's a lot shorter. And to make the length of a rocket, it just didn't really work as well. It didn't. So I would definitely try to use like a newer pencil and like a newly sharpened pencil, just for lengthwise. If you guys don't have that, that's okay. It was just a lot easier for me. So what we're gonna do is we're gonna cut this out. So you're gonna cut out the triangle first. It's a triangle, I meant rectangle, oh my gosh. I need to go back to school, clearly. So what we're gonna do is we're gonna wrap this around the pencil. So I'm gonna move this over here so you guys can kind of see what I'm doing. It's kind of hard to show. I don't have like a big enough desk for this. Okay, so you're gonna wanna, if it's easier, what I'm gonna do is I'm just gonna put a little bit of tape on the pencil just to wrap it around, and then I'm gonna let it go because you're gonna take this off the pencil, but just so you can kind of hook it on. And you're gonna wanna try to really roll it as much as you can, and then tape that back on. And you're gonna wrap this side as well. You wanna make sure it's all covered in tape, but not too much, because then you obviously don't wanna make your rocket too heavy. And you're just gonna push that. And you don't wanna have any holes in that as well, so keep going. So it says that you want to make sure it's not like too tight where you can't move it off the pencil, but you also don't want it too loose where if you want like this, it's gonna fall off. So it has like plenty of room to just move that pencil. So now, so also the instructions are on this, but I like going on the website because it actually gives visual instructions. I'm not good at reading instructions on paper. I'm better at reading them, seeing them visually. So that helps a lot for people who are visual learners like me. So the next step, what we're gonna do is we're gonna cut out and tape the fins. So the fins are right here as well. So we're gonna cut those out. Definitely when you do, right. So in the meantime, what I did, I actually moved these down a little bit just because that way you could tape around the top of it. So now what we're gonna do is you're gonna rip this tape in half and you're going to kind of pull this up above the pencil so that way you don't tape the pencil. And you're gonna tape the fins around each other. So you're gonna tape around. Which might take a quick second to do and you want to rip it in half because obviously a full piece of tape will not fit around both. But you can try. I just think it was just easier to do it this way. Yeah, they used half a piece of tape too. It doesn't say it in the instructions, but I kind of figured that one out myself. And obviously, if you kind of see something and you're like, oh, I don't know what to do, obviously you can try out, trial and error. That's how everything works. That's how people, you know, when they make rocket ships, there's trial and error for that too. Obviously, you don't want to have any errors when people go into space, but there's obviously trial and error before everything is occurring. So you're gonna wanna make a fin sandwich and like tape them together so they should be rounded. And then you're gonna make them up. You're gonna fold all of the little triangles into a 90-degree angle. So it says bend the part of each fin that looks like a triangle 90 degrees so that each fin is a right angle to its neighbor. Looking from the bottom of the rocket, it should look like a plus. So we're gonna do that to make it look like a plus sign. You can see is what I'm doing. So it should look like a plus sign. See how it's like a 1, 2? All right, now it says make the nose cone. So we're gonna push that to the end of the pencil now with the tip. And it says twist and pinch the top of the rocket body around the tip of the pencil to create a nose cone to form your rocket. Tape the nose cone to prevent air from escaping. So you're gonna want to use the tip of that pencil. And what we're gonna do is you're just gonna twist and twist. So it should create a cone shape. So now what you're gonna do is you're gonna tape around it. And you wanna make sure there's no air that gets into it. So at the top, mine has this like a little bit of a hole. So what I'm gonna do is I'm going to push this up a little bit. And I'm going to put tape around it because obviously we do not want any air to come out so then it won't even work. And then once you do that, I'm just gonna wrap it around. So now my rocket there should be no air coming out of it. So this will keep it from untwisting too when you tape it. So now the next step is it says measure the cone nose. So what we're gonna do is we're gonna take this measuring tape. It says measure the nose cone from the base where it's narrow. So it'd be from like right here to its tip and record the length in your data log on the rocket itself. Once completed, the rocket should be about 13 centimeters or 5 inches tall. So we are going to see how many inches this is first. So my rocket is 5 inches actually. So I'm going to show you guys. as you can see, I'm gonna show you guys this way, but it is 5 inches from top to bottom. So that is exactly what it says. And it says should be about, so if it's like a little bit over and a little bit under, that is okay. Obviously you don't wanna have like an 8-inch rocket, because that's not what we're doing. So we're gonna measure the top of the rocket. So this is, I think the side is centimeters. One sec. Why is there so many? Okay. Yeah. So what we're gonna do is we're gonna measure from this little gray point right here, and mine is 3. So from, from right here, can you guys see? Here to here, it's 2 inches. So this side with the bigger numbers are inches. So these are all little centimeters. So I'm just gonna show you here. So this is 1 inch. And then obviously this is 2 inches. So the bigger line in the middle is 1.5, so that'd be half. So if you, obviously this is centimeter on the side, but sometimes they don't give you centimeter measurements, so you would have to use the inch side. So as you see, I measure it from the cone. So mine would be 1 full inch, but it would also be 1 full inch on this side as well. So that is what, and then just to let you guys know, 12 inches is a feet, which would be this right here. 12 inches is a feet, but I'm no math wizard, but this is some stuff that I can easily teach you guys, so that's kind of good. So what it says now is in centimeters, we are going to measure the length of the cone and put it and log it. All right, so just to make it a little bit easier for you guys, I know I was using the measuring tape. I went up and got a ruler. I know you guys use rulers, so just to show you guys. So we're gonna measure the tip of the ruler one more time. So in centimeters, mine is 2 centimeters, but in inches, it is a little bit under a full inch. It's almost an inch. So what we're going to write in centimeters, we're gonna write 2 cm. So cm is the shortage for centimeters. So now what we're gonna do is I'm gonna write at the top of my, just up here, just for a little reference, I am gonna write 5 inches for rocket. And I'm going to write 13 centimeters, which it translates to. Okay, so just for future reference, so 1 inch is 2.54 centimeters. So mine wasn't exactly an inch. So technically, that is why mine is 2 centimeters. So if it was a little bit bigger, 1 inch, so 2.54 centimeters is 1 inch. So that is just to let you guys know for that. So now we're gonna prepare for launch. So what you're gonna do is you are going to remove the pencil and place it with the soda straw. All right, so now I'm gonna stick that, okay? And now it says 3, 2, 1, launch. So be sure that your launch area is clear and people and other hazards. Mark your launch point with tape or another object, then blow the straw to launch the rocket, and then measure the distance traveled. So what I'm gonna do is I'm going to stand on this, I'm gonna record myself doing it, but I'm gonna stand on a certain point of my floor and I'm gonna launch the rocket. So what we're gonna do is you're gonna blow in the straw and it's supposed to launch. And then what I'm gonna do is I'm gonna use this tape and measure how far it goes. And I'm gonna put pieces of tape down just for reference because we're gonna try it 5 times. So we're gonna do that right now. All right, so we are going to be doing our rocket launch. So what I'm gonna do is I'm gonna sit over here and I'm going to use this duct tape. It's Christmas duct tape, but that's beside the point. So what I'm going to do is I'm going to launch the rocket from a certain spot, and I'm going to launch it from the same spot 5 times, and I'm going to put a piece of duct tape as to where it landed. So I'm going to do it where the cone landed, the tip of the cone landed. And so like say if it lands, I'm going to put tape like right in front of it, and then what I'm going to do is I'm going to measure it and then do another try. I'm going to leave all the tape on the ground just to see which one landed the farthest. So we're going to take a couple scoots back all the way over here. It may not even launch that far, but we're going to try it out. So it landed way past my phone. So we're gonna put some duct tape on. So I'm gonna back this up for you. See how loud that is. Actually landed right there on my dog's food mat. So she doesn't get mad that I'm moving this, but so I'm gonna take this tape off. So it landed right here. So what I'm going to do is I'm going to put some tape as to where I stood first so I can measure. So I'm going to put it right here. All right. So now what we're going to do is we're going to take this. I'm going to take the bottom of it so it's just easier. And we're going to, you kind of want to make sure it is straight. Wow, this went far. Okay. I just stepped on my rocket, so don't ignore that. So it converts to 114 inches. So we're going to put that down 114 inches. So what I'm going to do actually is I'm going to show you what it is in centimeters too. Hold on. So in centimeters, it is 289. So we're actually going to do centimeters for this because I just read that to the centimeters. So we're going to do 289 centimeters. And whenever you write something down in like inches or centimeters, you want to make sure you label them, just so you know what you're writing about. Because if you just wrote 289, no one knows if you're talking about inches, centimeters, millimeters, stuff like that. So now we're going to throw that back there, and we're going to try this bad Larry again. There, and we're going to try this bad Larry again. I might be scooting around my house, but all right. All right. So I don't think this one went as far. Definitely didn't. Okay. So we're going to put that down right there. Don't mind my Patriot sweatpants. It's the quarantine look. Okay. Hope you guys are just as sad as Brady leaving as I am, so. So we're gonna flip that over, and that's 286. So 286 centimeters. All right, now let's do trial number 3. That definitely didn't go as far. Okay. So while you're doing this, a couple questions you can ask yourself is, why is it like they're not going as far? What you can also realize too is that, I'm gonna have to do this first. Hold on, guys. What also you guys need to realize is if you're not blowing the straw hard enough, it can also project like how far it will go. And also like the type of materials you use, the amount of times like it's fallen on the ground, because it can get damaged after a little bit of time. So obviously that plays a factor as well. So this one is actually 259 centimeters. So this one went much slower. So now we are going to do 2 more trials. So okay. I just want to show you guys why I made that face. And it landed in my dog bowl. So I don't know where to go from here because I didn't think that was gonna happen. So we can measure this actually. That's actually so funny. Okay. So we will not have a trial 5, as you can tell, because that's just not gonna work. But this was actually, so if you put this together, so it was 300 plus, okay, I'm gonna take this out now, but it was 300 plus 71. So we're gonna do, this one went 371 centimeters. So you're obviously going to do a trial 5, but obviously I can't because now my fins are soaked, and I didn't assume that was gonna happen. I was using the dog bowl to hold up my phone, but obviously that didn't work out. So yeah, so now my rocket just isn't gonna work. Just kind of dead. We can try it with the wet wings. I can try it and see how far this goes. I don't think it will go that far because it's now disintegrating, but okay, I think that, I mean, not too bad. Still went pretty far even with the wet wings. So what we're gonna do is we're gonna put that back on here, and we're just gonna hold on. This is really hard to do when your tape is like falling apart. Hold on, guys. Clearly this is, I don't know what just happened there. That's crazy to me. Okay. All right, here we go. Here we go. That one is 249. So actually, it's what obviously the least far, but it went pretty far for being completely soaked. So in the notes, I'm gonna write down just a little bit of things that I've noticed is when you don't blow the straw hard enough, it obviously doesn't go as far. Clearly trial 4, but I blew the straw a little too hard and it went into the water bowl, but that's beside the point. So yeah, so what you can do now is you guys can make adjustments on your rocket. So you can obviously make the cone a little bit bigger if you wanted to, a little bit smaller, you know, put some more tape on it to make it a farther distance because it's just heavier. Maybe make it just a heavier rocket in general, make it a lighter rocket. You guys can do all these trial and errors and see what you guys want to do and how to fix it. I would try to do it, but my rocket is now ruined, so we're definitely don't have that ability at the moment. Maybe adding more little, you know, wings to it as well, different cone, anything like that would definitely be helpful. I hope you guys learned a lot from this experiment. I hope you guys learned a little bit about inches and centimeters and how to measure and stuff like that. And I hope you guys enjoyed the whole science and everything like that. I personally love NASA. I love anything to do with rockets and stuff like that. I think outer space is pretty cool, how it's just never ending, and all the stars and the planets that we have in the solar system. I think that's pretty cool. So it was fun doing this experiment. It was a NASA experiment, so it was kind of cool knowing it was from that facility. I've actually gone to a space station in, I think, Florida. So if you guys ever have a chance to go down there, definitely try it out. It's something cool. It's like a virtual like rocket, so you see what it's like going into space. I actually had a panic attack on it when I was really little, but I did it again and I actually really loved it. So it's kind of crazy how going into space. So yeah, I hope you guys stay safe out there, and I hope you guys really enjoy this experiment and try it at home. Definitely don't get it in your dog's water bowl. That will not help. So yeah, so bye guys. I just want to add too, after you finish your experiment, you want to make sure you throw away all the materials that you've used, because you obviously don't want to make a mess. So definitely try recycling the straw or washing the straw. Definitely put your measuring tape away. And obviously when you can make the cone longer, as I've mentioned before, and do a bunch of other trials and take notes as to like why some of them worked, some of them didn't. So definitely try to make your cone larger, just everything you possibly can, you know, just keep adjusting it. It's a really fun experiment when you do it. And you can also like use just plain paper and cut it out and try to make your own rocket too, with like, you know, with the regulations that we did for the NASA experiment. So I would definitely try that out. Make sure you throw away all your scraps from cutting and everything, and put your scissors and your tape away. And yeah, so we're going to actually, I forgot to add, we're going to do one more step after this. I know I keep saying that it's the end of my video, but I have to add one more thing because I forgot to talk about this paper. So actually, before I talk about this, online on the NASA website, it says that once you do your project, you're allowed to share it. You can share it with NASA, which is kind of cool. So it says you can put it on Facebook or Twitter with your parents' permission, and you can email it to them and just show NASA what you guys did and what your experiment is. It's kind of cool to see some people from NASA could see your experiment, like astronauts and all that stuff like that. And you never know who's gonna see it. So what it says is distance traveled in centimeters and length of the nose cone in centimeters. So what you're gonna do is you're going to label, the origin point 0. And what you're gonna do, like that. So now what we're gonna do is we're going to label all of these little lines. So it'd be 1, 2, 3, 4. So that is what I'm gonna do right now. And I'm gonna kind of put that on here so you can see what I'm doing. So 1, 2, 3, 4. So I only did up to 12, but you can go as long as your cone like if you want. Because if you want to make a 24-inch cone, you can obviously make it longer, but mine only went up to 2. And obviously this is a bigger chart. So now what we have to do is we have to label this side. So this is the y-axis and this is the x-axis. So what you can also do to memorize the y and the x is that the y-axis has a long thing. So this is longer. So it's always the y. So it would make a wire shape. And then x is just the horizontal plane. So mine starts, the lowest point is 249. So what I'm going to do is I'm going to go by 50s. So I'm going to show you what I'm doing. 250, 200, 250, 300, 350, 400, 450, 500, 550, 600. Okay. So now as you can see, I'm actually going to turn it the other way. So now, as you can see, I wrote 50, 100, 200, 250, 300, 350, and so on. So I put space in between them. So technically this would be 25, this would be 75, 125, and so on. So you can put space in between. So when you're making a graph like this, you always want to have a label for the x-axis and the y-axis and for the name of your chart. So they already gave it to you, so you guys are good. But say if this was never here, like this wasn't here, that wasn't here, and that was here, you would have to label what each of the axes is. So that's just like a helpful tip whenever you guys are in math class. So yeah, and you always want to write what the the measurement is. So how it says in centimeters, so that way you know what you're measuring. So now, as you can see, is I'm going to use these points. So trial 5 was 249. So we are going to do, so length of nose, so we're going to do 249 here, and we're going to put it on that 2 axis right here. 371, so this is 75 right here, so we're going to do 71. I'm going to put a little below. My fault, I just messed that up. It's okay to mess up too, because I haven't done graphs in so long, so we're still trying to figure it out myself. So 259, we're just going to put that there. 286. So actually, I'm going to go use a different color, so that way if you do mess up, you can fix it. So here, 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 and then 371, which I actually did that one. Okay, so 289. So I'm gonna put that one right about here. And 286, which I'm gonna put that right here. So now this is all on one chart. The length of the cone and distance traveled in centimeters. So this is like the distance is up and the length is here. So when you guys make different size cones, you can obviously, it will have different measurements, but just because I did one size, it's gonna just show that. But say you did a 4-inch cone and it only went like 50, you would like label that there, and you just keep going and so on. If you wanted to change this up and do different trials, so like trial 1, trial 2, trial 3 instead, what you could do is you could like put them in different orders. So what I'm going to do is I'm actually going to show you what that means right now. So I'm going to move this over here so it's just easier in the light. So I'm going to cross this off and do trial. Right, that just to show you as an example. So I'm going to use a pink marker now. I'm like taking you around my kitchen. Sorry, guys. So what we're going to do is for trial 1, we're going to do 289, which can go right here. Trial 2, 286. 259 is the next one. So we would put that here. 371 would be up here. And 249 would be right here. So now 1, 2, 3, 4, 5, 6, or 5, obviously, so they would all be that. So what you could do is it goes down, up, down, and that's just to measure all the different trials and how far they traveled. All right, so I'm officially done with the video. I know I keep saying that I finished and I have like a million more things to add. So I hope you guys enjoyed, and I hope you guys learned a couple things. It was cool to refresh my own memory because I haven't done this stuff in a while. So yeah, I hope you guys do this at home, and I hope you guys share this with NASA. That'd be pretty cool if they could see it. So yeah, and then when you guys are done, you can either keep your materials or just recycle them. I'm gonna make sure you do recycle them because it is paper. And yeah, so be safe, guys. Bye.